Hello, everyone. Good morning, good afternoon, and good evening, based on your location around the world. I hope you have been a very good day today. You, as well as your family and loved ones, are doing good in this COVID 19 current situation. On behalf of Oracle, All India Oracle Users Group, I would like to welcome you today for our weekly webinar session. Just to remind you that webinar happens every Wednesday. So stay tuned with us on every Wednesday. Today we are lucky to have Anil Nair with us. He will share his insight on next generation of Oracle RAC. So very well, welcome to Anil. Before we hand off to Anil, I would like to remind you a few things. This webinar is being broadcasted on two channels, Zoom as well as YouTube Live. So spread the word, tweet about it, and share the information with your colleagues. The presentation will be shared with the registered participants only. You can fill the post webinar survey that will email after the session and you can view the presentation. So please keep an eye on your inbox after the survey link. At the end of the session, we will run online quizzes. So looking forward your participation and let's see who wins the prize today. For all your questions, there is a Q&A panel bottom of your screen. Please use that and we can tag them during our Q&A time. In All India Oracle User Group, we have culture to take a selfies. As we geographically far away now, you can take a virtual selfies and tweet on Twitter. To thank you, Anil, for his time for this webinar. You can use hashtags like AIOG virtual selfie, AIOG webinar, and @AIOG. So now I would like to hand over to Anil. Anil, could you please unmute yourself and you can start session now.
Perfect, perfect. Thank you so much, everybody. Thank you, Chandan. All right, I'm going to share the screen now. So let me know if you guys can see this.
You can share a screen now, Anil.
Yes, yes. Can you guys see this now?
Yes, Anil.
Perfect,
You can
perfect.
see.
Great. All right, great. So let's start. Thank you, everybody, for joining during this interesting times, so may say. Hope your family and everybody is safe. So with that, let's, hoping everything is good with your end, let's start this session. We're going to talk about the next gen Oracle RAC. Actually, this is something that I've been, intending to talk in the face-to-face, what we say, seminars, but unfortunately, due to this interesting times, as I say, we had to take a break from it and do it virtually. But regardless, it's very nice to see the enthusiasm of the registered folks. My name is Anil Nair. I'm the product manager for Oracle RAC. And as usual, I always say, please do take time to check the slide share and the LinkedIn, because I put a lot more information about these things in those slide share and LinkedIn articles. And also, as usual, if you guys want to reach out to me, that's my Twitter handle. Please feel free to reach out to me for any questions about these things. Having said that, let's take a second to acknowledge the safe harbor statement, just in case I say about some future product or future direction we're making. All right, everybody here knows what is RAC. I keep reiterating it. This is the only option to do what we call as active instances scaling, read, write, and hybrid workloads. Which means, as you see in this image, there is some sessions doing OLTP, while the other sessions and other nodes can do what we call as analytics or DSS kind of workloads. And this has been proven again and again by many of the customers. This is another thing that I'd like to highlight. I've been using this for a couple of years or more, where we show SAP workload scaling as we add nodes. Right? Now the thing is, they say, oh, this is such a, Anil has been using this for a while. What else is going on with RAC? Well, if you've been in the social media, you would have heard Oracle Autonomous Database being talked a lot. As I like to break up, what is an autonomous database? It's a bunch of Oracle Exadatas running RAC in the Oracle cloud. Obviously, there are automated data center operations included, but basically, a lot of the crux of this is built on RAC features. Now, you might say, how does that work? Now, I've taken the liberty of taking having some screenshots here. I don't know if you can see it, but that's not important. The part is when you go to your autonomous database and you try to scale, let's try to understand what happens. So if you go to your autonomous database UI and try to scale, you could put any number, like you go from 32, and enable auto scaling. What happens below the covers is that there are Oracle RAC features that help you scale. So, essentially, or what you do in the UI, in the backend, there is some way, some feature that Oracle RAC features that you're touching to get into and take benefit of all these things that you want to do. So what are those features that are used here? So, well, as you know, Oracle since last 20 years have been working on Oracle RAC, and there's a amount, like a humongous amount of features that we have introduced. This is just a small list of what we have. And just to make sure that this is the context, since 19C is out, this is probably a better way to talk about all the features. Now you might say, Anil, this is something that has been there for a while. What have you done lately? Well, that's the main part, right? The main part is we have taken these features and we continuously improve them. We continuously try to tweak them. We continuously try to adjust to what customers are doing, what their workloads are. So between 11G and Oracle 19C, you would see that some of these features provide you a 5x times scalability. So if, typical workloads which are affected by all these things that I'm going to talk about, we'll see a humongous jump in improvement. At the same time, between 11G and 19C, you'd see almost like a 6 times improvement in reduction of the brownout time. The moment the brownout time is lesser, that means you're more highly available. Now it's Anil, these are all marketing. Come on, you're just talking 4x, 1.5x. I want to know the details. So let's jump into some of the details. So before we get into what are the individual features, I want to set the thing on what is a new generation or next generation RAC, as we call it. Essentially, what we have done is we have taken major architectural improvements so that your applications can get better availability and scalability without any changes. There are, I think, two specific features that need a DBA input. The rest is more for you to know so that when you tune it, you understand how these things work. So essentially, as I said, the new generation RAC will provide you more and more improvements, architectural improvements, so that your applications can scale regardless of what type of application. The newer applications which require a lot of massive processing of data, and will provide you with what we call as minimum interruption or no interruption. Okay. Having said that, let's jump into some of the features. Now, what we have done, just for the context of this presentation, is we have divided the features into what we call as core database features, which I put it under scalability and availability, and then connection management, session management. This is something we have not talked about for a while. And then obviously the lifecycle management, because most customers or DBAs don't just manage one RAC database, there'll be multiple. So how do we help them manage multiple of them? So let's get into the scalability and availability. For the scalability and availability, you have to understand that while we start from a single instance of a RAC, you see that the single instance, the setting is exactly similar to what we have in non-RAC setup. Basically, you have the same buffer cache, same shared pool, same in memory, same miscellaneous. Yes, there is some component of Oracle RAC that we use, but they are more for internal use, and customer does not have to set any parameter for that. So let's understand what is in the buffer cache. So typically in the buffer cache, what we do from the RAC perspective is we have all the blocks that are depicted here, and then all the resource masters or the block master, which are depicted by the M. So our job, as in the RAC process job, is to make sure that all the buffers are tracked for their changes. And who is the tracker? So every block would have a master. Now, multiple blocks may have the same master. The masters can be on the same node or on the separate nodes. Again, this is not something that you have to set up or have any manual intervention for this. This is automatically done for you. What about the processes? Now, if you look at Oracle RAC process, the typical thing, incidentally, I was trying to find out what are the typical interview questions, and this is one of the questions. What are the RAC specific processes like LMS, LMD, LCK, LMON, and all that? However, over the years, as you see in the Oracle 19C reference architecture diagrams, you would see more and more processes have been introduced. Essentially, if you see, we have in what I call as more fine-grained processes introduced over the years. So if we have a DIAC process, now we have a DIAC 0 or DIA 0, which is running the hang manager. We have GCR process, which runs the global conflict resolution. We have all these additional optimized or fine-grained processes to ensure that the overall work is distributed, so that as you add more and more CPUs, as there is more and more memory, we can actually scale. So a single LMS or a single LMD or a single LCK does not get bottlenecked. So there are these many improvements. One of the things that I would like to talk about is this ACMS CF rights. So if you have been using the earlier versions of Oracle, let's say 11.204 and all that, you would see sometimes that the control file enqueue becomes a hot point of contention. Now, for those of you who want to try it, you could actually set up a test system with very small redo log size and then try to run a workload on it. You would see that the more log switches happen, the control file gets more and more busy, and it becomes really inefficient. What we have done is we've taken obviously the best approach we have recommended. So if you run this over an AWR report, one of the recommendation would be, hey, resize your redo logs. Now, on top of that, we have also broken up the functionality of control file updates into separate areas. There are sometimes we just need to read it. There's no need to take a lock on that at that time. Sometimes we need to write it. That time we need a lock. So we have broken it up and segregated into separate components. That way, we are more optimized. We are able to, scale better. So this is some of the important things that we have done. There's one other thing which we have started in 18C. If you see on the right-hand side is, if you do a PS, and you would see that the LMS is running in a timeshare mode or TS class in 19.4 and RR mode in 12.2. You'll say, Anil, this is something wrong. There is something set up, misconfigured, because LMSs are supposed to be running in what we call higher priority, or having more resources of CPU resources to run. Well, this is because of the way that threading is done with PS. So starting with 18C almost, what we have done is LMS process has its own threaded processes. So if you look at the specifically the L option, you would see that we get the TIDs of this. So you see here that the LMS 0 is running with RR, and then the LMS slaves run in TS mode. So essentially, you need to update your PS command output if you're trying to find out these details. The higher point is this, simply that we have optimized the LMS so much that we have made it threaded, and we also have made it threaded in that such that in the sense that certain LMS processes run in higher priority, the LMS slave run in typical normal priority. Now, what does this give you, right? So this gives you a lot of benefits. So if you don't take my word, we just tested this with some reconfiguration performance with large buffer caches. So if you look at it, the first test we ran, we had 8 LMSs on a 2-node rack. And then we have a lot of what we call as updated or changed buffer cache blocks in the buffer cache. So you see that between 25 gig to 50 gig to 100 gig, the reconfiguration time has, although from 25 gig to 100 gig, it's a 4-time improvement, the reconfiguration time is only like less than 3 times, which is very good timings. This is because of this optimization in the process architecture that we have. Also, then you remember that if you have 100 gig cache with a 2-node rack and we increase the number of LMSs, you can see that the reconfiguration time, which was 8.3 seconds for 100 gig, has considerably reduced. So essentially what we're trying to do is with all this performance, all these optimizations, which by the way, you do not have to do anything except maybe upgrade to that version. We'll take care of all of these things below the covers. Now, all those things are really, really great, but does it help the customer? Well, yes. So our point is very simple, right? If you take a user who's connecting to node number 4, let's say, and he wants to get a block, but the master block is in some other node, the master block tells him, hey, go to node 2, but the block is with some old SCN. Now he needs to apply some, undo to read it so that he gets the answer. Now, this doesn't change. However, what changes is we call this the worst case scenario, in the sense that even if you have a 16 node cluster or a 12 node cluster, your worst case scenario is always three-way communication, which means you have node 4, node 2, and node 1 in the picture. Node 3 is pretty much not involved in this architecture where we need to go and get your data from the remote node. All of our performances are therefore, our performance optimizations are therefore trying to make sure that we reduce this three-way communication to maybe two-way or even directly one-way. So essentially, what we want to do is we want to make sure that during startup or during, whenever a query needs a block, the block master should, if it is co-located where the block is, hey, that'll be great, right? Because we have reduced one hop already. This is amazing if we can do it. Well, that's what we're trying to do, and we have done in two ways. One is to do it during startup. When you start up, you want to somehow be able to co-locate the block and the master. And then during runtime, we will utilize the features of DRM for that. And I'll talk about where DRM has changed in 19C. So with that set as the context, now let's talk about what are the specific RAC features. I divided into two sections: scalability and availability. You can argue, Anil, this is also availability feature and something is also scalability feature, but just so that we have an ordered way to approach this, I want to make sure we talk about this in separate context. I've talked about this somewhere in 3 years ago, and this is becoming more and more common nowadays. Even other day, I got a tweet on Twitter saying something about this. I keep saying this, yes, cache fusion always used to be the point where we send the block across using the private network. But there are improvements in technology in the storage side specifically that sometimes we have to change. So in this case, if you see a block that is on node 1 required by node 2, we send it over the network. But if there is any congestion on the network, we would send the block directly from the disk. So essentially, we'll give them the permission to read it from the disk. Now, we have internally monitored the network rates and the I/O rates on the storage layer, and we can choose or dynamically change from one to other. This is done again without customer or DBA involvement or anything. We try to do it, and again, you'd say, Anil, how do I find out? Well, this network congestion and all this information is in the AWR report, which will go about in the end of the thing. Okay. We have the LMS slaves. Remember, I talked about the LMS slaves that gives us the amazing performance. Now, why do we do LMS slaves? And now, why not just have a lot more LMSs? Well, to understand that, we need to understand this typical issue that we used to face earlier. Now, if you look at this graph, you have a graph where your transactions per second is growing. And if, your response time is pretty good, except you come to a point where your response time is kind of like, suddenly picking up and going away. Such kind of workloads are really, really hard to troubleshoot because by the time you look at an AWR report or you look at an ASH report, the thing is gone. So in one of those things, we found out that the problem is that how the work comes in. So typically LMS works on what we call as a first in, first out fashion. So if you have 10 processes on the queue saying, I want certain block, I want certain block, it goes from one to the end. Unfortunately, what happens is if certain process requires a block which has an older SCN, that means LMS has to do a lot more work to apply undo so that it can give a consistent block to that process. It just gets stalled because the rest of the guys are not able to do their work. So what we have done is added an algorithm in LMS where if there is a certain amount of undo to be applied or certain threshold we cross, then we just basically ask the process to work with the CR slave, and we continue working on the queue. That way, your outliers are reduced. Now, again, the default is one slave, and we automatically spawn as many as we need. And we have these statistics in the AWR report for you to look at. Of course, this is more of a for your information because we are actually solving a problem here. Now, remember the part where I said, hey, we need to also look at how do we ensure that the block master is always co-located with the block. Now, what we have done it is we have done this based on information that we collect. So what I'm trying to say here is, if you have services and if you're connecting to a service, let's say this is the sales service is adding or updating the sales table. This is accounting is updating the accounting table. Then what we try to do is we try to collect the information that, oh, remember node 1, we have sales table being updated when the connections were connected using the sales service, similarly for accounting and similarly for so forth. We use this information, we actually persist this information to the database so that when you restart fresh, the block masters of sales table are co-located with the blocks of the sales table here. That way we're trying to reduce the hops. Now, remember that as we get to 18C and 19C, initially we used to store this at the database level. Now we are trying to store it at the PDB level. So access level statistics are stored in the PDB dictionary, not at the CDB level. This helps us even in isolating the PDB workload so that a PDB operation does not affect other PDB operations. The other benefit of this is, whenever you're trying to apply, do what we call as scheduled maintenance or planned maintenance, we have the problem where if the processes or the connections working here has to fail over to node 1, then essentially some of their buffer cache information may be lost, because if there is a query here which has been querying on table X, which is a very large table, this buffer cache would have been populated, would have been warmed up. But when you fail over, it has to resort to physical reads. Well, what we do is, for the plant maintenance operations, we try to fill the buffer cache. Now, obviously, yes, you can argue that, Anil, what happens if the buffer cache is already full on node 1? Well, then it follows the typical buffer cache issues. So, for example, consider a single instance. If the buffer cache is already full and there is some new buffer cache required to be filled in, then we go through the same algorithm as in a single instance case, where the older buffers are written out so that we can make sure that the current queries do not have to resort to physical reads. So this is something that is new. Again, in the context of hangs, this is something that I always hear, that, hey, there is this one session which is causing complete hang on my side. Now, again, the database is not hung, it's the application that's hung. But regardless, it's a DBA. If you ask, hey, does Oracle scale? Yes. Does Oracle provide high availability? Yes. But then, if your application is written in such a way that it can cause hangs, then we are in trouble. Now, unfortunately, so far, we used to always say, hey, here's your hang analyze, go talk to your application developer. Well, now what we do is we actually monitor, we detect, and then we do a hang resolution. What that means is we take an action on that hang. Now, we can also traverse through layers. What that means is, if the hang is on a process which is waiting on an ASM instance, response from an ASM instance, which is running in separate node, maybe we still can figure out these things. Now we have been having this for a while, that in 18C, now we also let the hang manager manage or resolve deadlocks too. So this is this really interesting feature that is pretty much provides you a DBA with the tool, so that when it takes action, it also provides you a lot of information. So if somebody comes to you and say, hey, well, how did my session die, you have all that thing. Now, new in 19C is also the integration of DRF and hang manager, and I'll talk about DRF a bit, but just think about it as earlier, every individual component used to manage and monitor their own detection. Now we have a centralized repository which can be utilized, and we'll talk about DRF in the subsequent slides. Right. So this is the way you would look at it. Now, again, you don't have to read all the trace file. This is the important part. You would see the 32701, which means essentially that Hang Manager did something, and it tells you the reason that the automatic hang resolution was performed to free a significant number of affected session, and it provides you a lot of details, gory details that you can look at the session, what the SQL it's running, and all that and all that. Let's jump on to availability now. Now, availability, we have improved some of the ways that we have been doing what we call as node eviction. Now, what is a node eviction? Well, when certain times a node or a bunch of nodes can get sick in the sense that it is not performing the things it's supposed to perform. In earlier releases, we always used to have this pattern where if there is a split brain, we have the lowest number node survive. Now, lowest number node in this case is 1, 2, 3, 4. So 1 would survive, or 1 and 2 would survive, and 3 and 4 would get evicted. Now, what has happened in the recently is we found this typical customers, when they add nodes, they purchase newer systems. So you actually have this problem where 3 and 4 nodes had more CPUs, more memory, more work. But what did Oracle do? We evicted 3 and 4. So now we have a mechanism by which we call it node weighting. Essentially, node weighting allows you to determine where is the work in majority. So if there is a work in majority, then if there is a split brain, then we want this side of the node to survive. So even though the lowest number node is there, but it's running less number of services, and this side is running 3 services, so obviously this side of the nodes would survive. We didn't stop there. We also found out what we call as secondary errors. Now, what happens is if the similar issue occurs, excuse me, there are 2 services on one side, 3 services on this side. Now, obviously, you want node number 3 and 4 to survive. But then we found out that 3 and 4 also has a public network card failure. So what's the point of keeping these guys up? So we kind of have 1 and 2 survive. What happens if there's an equal error? Like, there are public network card both sides. Then we fail back to a scheme where we let the lowest number node survive. Now, these are all optimizations based on input that is provided by you as customers. And then this is the final one. This is one of the only things, like I said, other than the other feature that is what we call as scalable sequences that's coming up, where a DBA needs to go in and take some manual step. And again, this is optional. You don't have to. Now, you could come to me and say, Anil, this is all great. Your CSS is doing an amazing job, but I really want to be in control of what nodes get evicted. So yes, we provide you with a thing called CSS critical. Essentially, there's a CRSCTL command where you can depict or choose a node as critical. So if you say that this node is critical, you have defined this. Even though this guy has a lot many more services, we will keep this side of the subcluster in and evict the other guy. Now, there are 2 ways to set what we call as CSS critical. One is at the node level and one is at the service level. And if you set it up such that it happens that node is set up for this side and service is set up for this side, then obviously, again, we don't know what to do. So we'll go back to our previous mechanism. So the idea is not just to evict, the idea is also to smartly evict. Now, you might say, hey, how about you prevent to evict? That's a good question. And what we have done is we have worked with support over the last 5 years, and we tried to figure out what is the leading cause of node evictions. And you'd be surprised. It's not a network issue. It's not a or misconfiguration. It is mostly over provisioning of memory, where people just go and allocate more and more memory, so that during crunch time, what happens is the OS ends up swapping, and once it's swapping, it cannot stay up because the swap daemon takes up all the CPU, and boom, you have eviction. So what we have had is we have this thing called memory guard, where essentially memory guard detects that memory is low, and then it tries to relocate a service. Now, obviously, you're right. It does require some other place where the service could be moved. Yes, that is a thing, but we are hoping that not everybody runs all the 4 rack systems at 90% capacity, right? You're typically trying to make sure that there is some headroom. So in this case, we will transactionally move the services, which means your connected sessions can continue to work, but the older, newer sessions will be redirected to other nodes. As the memory in this gets better and better, we will move the service back. So that's our attempt to try to reduce what we call as the leading cause of node evictions. Now, okay, what happens if there's an eviction anyway? Well, if there's an eviction, then we need to go and do what we call as recover the changes made by the node which has been evicted. Now, what are the changes? Well, the node which was evicted could have been doing some transactions which would have had some changes due to committed transaction, and we need to do some rollback for uncommitted transaction. So this is something that is new with 12.2, and I have a really lot more informational blog that covers a lot more details than what I'm trying to say here. But essentially, the main thing is this, right? With Recovery Buddy, we are able to do this reconfiguration, or what we call as the brownout time, to be 6 times faster, which means that you have more high availability. In 19C, we have this point of fast track non-master resource. I'll explain to it as I explain what is the functionality that we are trying to solve. The functionality we're trying to solve is, before this Recovery Buddy was involved, we used to have this high-level 5 stages to go through in order to make sure that we have evicted the node that is found to be having a problem or has been already rebooted out of its system. What does that mean? First, we need to detect, then we need to evict, we need to do some thing called as an elect recovery. That recovery guy has to redo and apply recovery. Now, as you can see, with Recovery Buddy, we have taken care of optimizing some of the steps. What does that mean is, we detect the issue, we evict, but because Recovery Buddy already has found out that which node is gone out, so that the Recovery Buddy does not have to go through this phase of electing a recovery guy and then reading the redo and applying recovery. So we have essentially fast tracked all these steps. Now, how does this work conceptually? Conceptually, what happens is, during startup, we attach a Recovery Buddy to an instance. What does that mean? So if you see here, instance 2 has a Recovery Buddy in instance 1, instance 3 is a Recovery Buddy in instance 2. So if instance 3 gets evicted, then Recovery Buddy here takes over and tries to do the recovery things for instance 3. There is also an RMS 0 process on each Recovery Buddy that maintains an in-memory area. So as I mentioned earlier, it is getting much faster to have the storages. So when you do read writes, there is what we call as changes to be done. So you have to always go read, then write. Instead of that, if you can just read it from the memory and just make all the changes in one shot, because of these changes in this storage, the SSDs and NVMEs are now able to do this much faster, which results in the Recovery Buddy completing the changes or applying the changes far more quicker. So this makes these improvements, like I talked about earlier, about 4 times and 1.5 times faster and all that. Along with this, now we have the issue of planned outages. Now, this is something that is coming out. Essentially, what we are trying to do is, before this feature, if a node is going out or going down for a planned downtime, the rest of the nodes have to come in and do recovery for that, because there might be changes or a mastership that needs to redisperse and all that. With this feature, if you pay attention here, I'm trying to take away node 3. What happens is, the mastership or the master itself are moved out before shutting down the node or instance. So what happens is, there is lesser work to be done, so that the reconfiguration or is taking even lesser time, close to 0, in many cases 0. Now that we talked about overall high level features, I'd also like to talk about a little bit of the HA and scalability features for certain specific options that you have. So data guard comes first. We talk about the data guard feature. So before this feature, you essentially apply, redo on your standby site from one of the nodes. So even though you have RAC, you would say, okay, Anil, I'm having RAC, but I'm only using one of the one of the nodes to do what we call as recovery or media recovery. Well, we have improved it now so that you could use what we call as MIRA, or multi-instance redo apply. With multi-instance redo apply, you can see that we are now able to utilize both the nodes and therefore be able to apply from the changes from the primary very rapidly, so that your standby can keep up so that if there is a problem on the primary side, your standby is up to date, and therefore it's faster for you to do like what we call as a failover or switchover. Multi-tenant, some of you guys know that as we go into newer releases, you would have more and more features. Yeah, I see some people have raised, and I would probably take this at the end if you don't mind. That way, we don't have interrupt the flow. I would answer all your questions at the end if you don't mind. Now, multi-tenancy is, that there is not going to be a non-CDB option available. It's going to be, everything is going to be what we call as, multi-tenant or PDB architecture. So what does that mean? Before this PDB architecture came along, we had this central synchronization point, which is called as domain zero. What does that mean is a domain zero is a central synchronization point where operations like database start, database stop, and all that are essentially done, where there has to be a synchronization point for that. This was fine until a lot more customers are starting to use PDBs. So how does this happen? So now, if you say before the PDBs, or even when PDBs were initially introduced in the earlier releases, if you have 4 PDBs, we have this single synchronization point. The resource hash table, as you can see, consists of blocks that are spread across different PDBs. So if I have to reach a block I have to actually traverse the block all the way to come to here, right? Now, this means that certain PDBs, when you consolidate, you might have some issues. So what we have done in the later releases in 12.2 and above is essentially we have spread it out. So we have taken the centralized synchronization point and spread it out. So as you can see, we have now 4 hash tables for the 4 PDBs. So if I have to reach a hash table for the blue PDB, it's much faster. As computer science 101, as I say, the smaller the hash table, obviously it's much more efficient to traverse it. This allows you to consolidate as many PDBs as you want, and ensuring that one chatty PDB will not affect the performance of another PDB, because we are actually trying to make sure that that the access patterns of this are different. This also provides you another improvement. So let's say if the gray PDB is starting or stopping, well, the other PDBs don't even need to know about it. So there is nothing to what we call as synchronize for the rest of the PDBs. This is better explained in this graphic. As you can see earlier, before this feature, the messages were sent at a CDB level. So if you take any kind of PDBs that are talking on multiple nodes, regardless of whether it is intended for that PDB, the messages were all sent across for all the CDB level. With this improvisation, what we have been able to do is we are now able to send the messages just between the PDBs. So for example, in this case, you see the yellow PDBs are only ones involved in this messaging, because at the message layer, at the DLM layer, we know this message is intended for which PDB. So this is really optimized way so that we try to reduce the chances of a noisy neighbor or noisy PDB affecting the performance of other PDBs. Okay. Now, there is another feature because that helps with this. Now, for example, let's say you have this case where you have two sets, the PDBs spread across different nodes. Now, if you see, I've kind of color coded it separately. So all of this red PDB, the light green PDB, the yellow PDB, they are what we call as essentially singletons. What that means is they're running in only one node. Now, what happens is if node B gets evicted, prior to this feature, this guy has to go through a reconfiguration. But with this new feature, if the red PDB is not running on any other node and that node itself is going down for some reason, this red PDB does not need to do anything or have any, wait for reconfiguration. Why is that? Because remember, the reason we used to wait for reconfiguration is initially we were worried that there might be changes for the red PDB in this instance. But since we know that certain nodes are not even involved, in this, we could actually take this action of taking away this wait. So we have kind of optimized this a lot on that. Okay. Moving on with RAC in memory. Now, with RAC with in memory, we have this feature by which you can put your in-memory column units, excuse me, or as it's referred to as IMCU. you could spread it across different nodes. And then if you use the auto degree of parallelism, we will start the parallel query correctly on the node where that IMCU is there. Now, this is amazing with RAC. And also with Exadata, we actually have copies of this. Well, the reason we have it only in Exadata is because, remember, these IMCUs are not static in the sense that these IMCUs could be made up of sales table, which are continuously being updated. So every time you update, the row format and columnar format is updated. Only on Exadata with its RDMA capabilities, we can make sure that these things can continuously perform at the rate the customers want. And therefore, we have this unique fault tolerance feature only on Exadata. Which brings us to Exadata. Now, I keep telling about Exadata that Oracle RAC has perhaps one of the best platforms to scale up on Exadata, because Exadata provides for us what we call as almost like the really, really fast private network without, with lowest latency as we can. That's not just the simplest thing. Also, we in the RAC team has optimized so many things, so many features for Exadata. For example, if you look at a typical node eviction, because the operating system does not provide us a way to find out if a certain node is hung or not, we utilize what we call as network heartbeats and disk heartbeats. So we have to have some threshold. So typical network heartbeat is 30 seconds. So it could take up to 30 seconds, well, correctly, technically 27 seconds for us to detect a certain node is not responding. Well, I say up to, not that is not a finite value. Certain issues we can detect much faster. But regardless, for the purposes of this conversation, let's talk about 30 seconds as a number. With Exadata, we utilize what we call as a subnet manager. Again, regardless of InfiniBand or Rocky, we're able to talk to the network and be able to find out quickly what happens. So you can see this, our numbers are 0.8 seconds. Well, as luck would have it, I have a trace file excerpted from here. You could see that when I tested it, I found that when we inject a failure, these guys could come back with 0.733 seconds, much less than the advertised 0.8 seconds. So eviction is detected in less than 1 second. So once you detect the eviction and it add on all the other features I talked about with recovery buddy and all that, you can see that our numbers are going significantly down in terms of availability, in terms of having lower brownout, and therefore scalability. For the scalability aspect, we are using more and more features of Exadata, we call as RDMA. For those of you who don't know, RDMA is like the remote direct memory access. So this is essentially offloading a lot of the LMS work to the RDMA. So we are trying to move the broadcast and commit and other things. Now, again, a lot of this information is there in the slide share. I'm not going to talk about it again. But if you have questions, again, like I said, you have my Twitter handle. Feel free, or at the end of this, we can talk about it. The right growing index is another problem that we have. Essentially, a right growing index is sorry. Oops, sorry. A right growing index goes in the pattern where an index is there, and then you break it up into multiple blocks, because the index gets so filled up in the block. So the problem with this is that we need to have an optimized way by which to take care that even though this is not a RAC problem, it does affect what we call as RAC scalability. So we have done some of the changes, and I'll talk about the specific changes, but you can see that with these changes, even on a right growing index problem, we are able to scale much, much better. Now you would say, Anil, how do I even detect if I have a right growing index problem? Well, right growing index problem, you would see these kind of things in your AWR report. So if you see that in this, you have 32% DB time and 18% DB time for the buffer busy release and buffer busy acquire. This is about 50% of the buffer contention. And you would see who's causing that. It's for global NQ handling. So if you look at it, you see that 21.7 is for NQTX index contention. So this is a good way to find out if your workload is being affected by it. Now that you have two fixes for this. Now the fix number one is automatic. We have done it below the covers for you, which is essentially we have rewrote our algorithm to do the index splits. So if you look at before the change, we would have 5,000 number overall throughput. Now we are like 9,000 numbers. So we are doing much, much better. So it's almost 50% improvement for that. The other thing you can do is sequences. Now, typically indexes utilize what we call sequences. And when you use sequences in certain way, again, this is not a rack problem, but this will affect your performance. And you would see this in an AWR report the following way. Um, uh, I'll talk about how we can help you fix it. Now, this is where again DBA has to do manual intervention. Remember the 2 points I said, which gives you a choice to do manual intervention. You don't have to do it. It's a choice that you have. So in sequences, you can create what we call as scale. And what we do is we utilize a node number along with the sequence number so that the individual nodes would get like kind of a bigger chunk of these sequences so that they don't have to actually constantly keep tripping over each other. So, but again, this requires the DBA's intervention because certain businesses have certain tables which require certain sequences to be only growing and not missing any entries and all that and all that. So you need to take care of that. Therefore, this is something that DBAs had to manually intervene. We also have an in-memory transaction table, so that this is again in Exadata, where we have been able to reduce the time waited for certain workloads. So you can see from baseline to the improved, you see a 14x times improvements. Again, this is done in a lot more detail in my blog. So we can talk about, you can look at the blog, but essentially this is a feature only available in Exadata. We also have this undo block, RDMA read and commit cache. What does that mean? So what has happened is whenever you try to insert certain records across multiple nodes, we need to be able to read the undo from the other side, because it is possible that out of the hundreds of records you're committing, there might be one that might have rolled back. So we need to keep a track of this. Earlier, we used to rely on sending messages across each other between the nodes. Now we are able to do it what we call using an RDMA read. So we have a small in-memory area where this is updated constantly. So we don't need to send and receive messages. So if you remember the transaction table or the ITL entries in the block header, even though we need to read just like say certain number of bytes of it, we have to send the entire block. So we now do not have to do this. We can read what we call what we need and put it in the local memory cache so that the ongoing transactions can benefit from that cache and do not have to do constantly the sending and receiving blocks. Same thing for Smart Fusion block transfer. So if you see in typical generic system, when you do a log write, you need to get confirmation from storage that the log has indeed been written to. Without that, you cannot just send a block from node 2 to node 1. Why is that? Think about it this way. Node 2 has changed some blocks here, and if it sends it to node 1 without writing it, and there is some crash on node 2, then node 1 will make its own changes and write. So the changes made by this guy will be lost, and therefore, if they need to recover up to that change, we cannot have that. Now, in Exadata, what we do is we can do this. We issue the log write. We don't have to wait for the acknowledgement of storage or log write completion. We could send this earlier. Now, why we could do this on Exadata and not on other system is because on the Exadata store itself, we run a software which can understand block structures, and therefore, if node 2 crashes before node 1, we are able to order the writes in such a way that we are not, we can make sure that there is no issue with recovery. And this feature itself provides 40% throughput and 33% response time improvement on heavily contended OLTP workloads. Another thing about excuse me, Exadata is the Exafusion. So Exafusion is something that will help even further improve what we call as the underlying InfiniBand or Rocky setup. Now, as you can see, a typical Rocky or InfiniBand infrastructure can give you almost 2 times the performance, but with Exafusion added on, we get 3x the performance. What does that mean? So if you look at this, essentially, whenever you're trying to send and receive messages, you have to send it to global cache. There's an IPC layer involved. There is some context switching. Then we go to sysland. There's a driver and IP stack. There is some context switch. There's a NIC and there's a wire. Now, all this adds what we call as context switch overhead whenever you want to send and receive network information, right? So we have done is, this is how I call it, used to happen. So from the SGA, we go to the OS buffer to the InfiniBand. And what we have done is now we directly bypass it. We directly write from the Oracle user land into the InfiniBand. So we don't have to go through this constant user mode context switches. This is done by this new process called IPC0. And IPC0 is responsible for all of these guys, all the what we call as execution capabilities. The good thing is we used to we have automated it automatically. The thing is, to for you guys to remember, is remember that execution enabled is now deprecated, because now we want everybody to use execution. And that's the main guideline, which gives you about 3 times improvement for typical sending and receiving what we call as blocks across the nodes. Again, with all these features, you can see we have reduced constantly these numbers, and there are a lot more information here. So if you feel you need more information, go there and read about those things. And again, feel free to tweet me for questions. Now we talked about this database and all that features. Now, again, nobody argues that, okay, Anil, the databases are up and running, but hey, my clients are still stuck. So let's talk about client. Now, clients, remember that even though you connect, regardless of you connecting through OCI and or connection pool or ODP.net or whatever, you go through what we call as a SCAN or single client access network, regardless of number of nodes. Now, one of the things that people don't know is that we have a mechanism called ONS, which can notify and keep updated the connection pool. So if a connection comes in and if one of the node is actually not there, then we automatically are able to tell this to the connection pool without the connection pool having to find out. So this is something that I'd like to highlight here. So for example, let's say you have a connection coming in, and as the connection comes to the scan goes to a particular node. And if the node is down at that time, then we automatically provide what we call as a gratuitous ARP, so that nobody else has to wait for TCP/IP timeout. And instead of waiting for that, we say, guy, why don't you try something else? We go to the other node, we're good. Now, while this happens, we also send a notification to the connection pool that, dude, this guy is down. Don't even try to connect here. So by this optimization, we are trying to actually make sure that, yes, your database failed over, you have RAC and all these features provided you with all the availability on the database side, but your clients can also get benefit of these things. So this is very important that the ONS does update these guys. In order for the benefit to be taken, you need to make sure you're using the connect string correctly. And this is what I call out. The 2 things that you really need to make sure is these things, the transport connect timeout and the connect timeout. Now, what I did is I just did a small test on my system where I had, set up an issue or a network, a simulated network problem, and I did not. So these are all commented out. You see that when I try to do a TNS ping, I got 62,000 milliseconds, almost a minute wait. This is the default, what we call as TCP timeout on Linux. Hey, look, for when I removed it, I could get it in less than, I took out all those time out. So essentially, I was able to get so much better numbers by this. Now, these are good entry numbers. Again, sometimes you might have to tune it for your systems, but these are very good numbers to start with, and we recommend that. Another thing, remember we talked about how we can have the blocks and the block masters co-located. You could actually also have this idea that, hey, your sessions that are connected, I want it to go to a certain set of nodes. So you could run different types of workloads on different kinds of nodes, but you could what we call as tag your session using the co-location tag. Once you do co-location tag, when Oracle has a choice to put your sessions on different nodes, we try to co-locate them so that they're not, going all over the place and doing, what we call as causing more block pings and all that. App continuity, is something essentially what we have to prevent what we call, or what, a session or a failed node to be causing a problem for and being reported to the user. So essentially, we're trying to mask all those things. So if there is an issue, if a node is gone during the middle of a transaction, we try to automatically move the work somewhere else and do the work, complete the work, and return success to the user. Now, I'm not going to talk much about app continuity because Ian will probably do another session, but this is just a high-level thing of how to enable it. You essentially modify the service with this failover type and the commit outcome. There is some AWR checks you can run. Excuse me. There's an what we call as Aura check, which you can run to make sure that these things are being protected. With 18C, well, we even made it better because we introduced what we call as transparent app continuity. What does that mean? Well, earlier, you remember we had this thing of going through what we call as a connection pool. Now we can actually go directly for those sessions. So if there is a problem, we can still benefit from all this app continuity features. So this is, again, like I said, going to be probably done again in another session with a lot more details. Now, as a very high level, you don't know what to use. You gave me too much information, Anil. Well, this is a small table, so you can kind of go through and say, okay, this is what my thing is, and I would go with this or app continuity or whatever. And again, this is just a very small 2-minute update on what are the session things that we have. At the side of what we call as efficient lifecycle management, typical lifecycle management issues involve like installation, patching, manage, and I'll talk about what it means, and tuning. Now, install. Now, I hope everybody realizes we have this new thing called as the gold image or customized gold image. What that means is, if you in the past had to go to a certain version of Oracle, you'd have to download some base release and apply patches and apply patches, and you need to do it even however many times you need to deploy. With this new gold image thing, you basically unzip it, the whatever you download, you apply your RUs before, so you don't need to even do anything, and then you can zip copy and deploy this to multiple homes. You do not have to worry. So this is very important, that as this feature provides you with the agility to deploy the GI images much faster. The important thing is, even if you do this stage, OPatch provides you with all the information about what are the PSU or RUs that you applied on the base release to create your custom image. And since we're talking about versions, remember that 19.7 version is not changing from the older version scheme. So 11.2 and 11.1 were supposed to be different, the way the versioning scheme is. And now again, 19.7 has changed the way it is. So 19.7 is version 19 RU7. So nowadays it's possible, but not recommended, to have a 19.4 GI with a 19.7 database. So how do you do it? Well, you could do grid setup is the new command, and that is one command to do all these things: install, upgrade, add node, delete node, and all that and all that. There's this new feature that when you try to upgrade, it tries to, or you could use a dry run for upgrade. Dry run for upgrade means it is essentially going to go through all the steps without actually physically doing any changes. So you can find out all the things beforehand. I'm not going to go through this laundry list. Essentially, these are a lot of the steps that we used to do in earlier releases that we have optimized in 12.2. Again, starting 19C, we actually have provided a lot more information. So if something fails after a patch, you could just see the trace file. It tells you exactly what it is. Like in this case, it tells that I expected the gypcd.bin to be grid, but I found it to be Oracle. So please fix it, or, so you have a way to automatically fix your problems. In the patching side, we have this switch grid home. So switch grid home allows you to apply patches which are typically done in place to out of place. Now, there are obviously so many benefits of out of place patching. We're not going to go into them, but now we have grid setup. You could actually apply patches such that from 19.3 to 19.7 could be a different directory. You could just do switch grid home as part of the patching operations. Mike Dietrichs like to talk much about auto upgrade, so it's been fully integrated with Aura Check, and it also does for RAC homes, servctl minus upgrade, or for the home. So this is very cool. So the full integration with other tools we have. You can see that from the screenshots. Management. Now, management essentially includes compute side management and storage side management. So let's talk about some of the compute side management. You say, Anil, this is all great, but I have hundreds and hundreds of systems. I don't want to be in the business of doing this manually. Well, you have what we call as this one-click install, patch, delete. So you have FPP, which is the new name for RHP, to be able to do all of these things. You could also utilize what we call as ZDM and ZDU. Again, one-click things. all of the things you can do manually, but if you want to do it automatically or with one click, as I say, you have this choice. Filter driver. Filter driver is one of the things. It became a bit late, but now it's there. It essentially prevents system admins from accidentally overwriting what we call as ASM files. So if some disks have been provisioned for ASM and you have filter driver, we will try to not try. We will protect the devices. We also recommend using what we call as the new flex disk group, which you can do what we call as quota management. So if you consolidate multiple databases, you could actually set up quotas at the database level. And now you can do what we call as quotas at the PDB level. So if you consolidate many PDBs into a CDB, you can control the space usage of individual PDBs. Which brings us to tuning. And I have exactly 3 minutes. But this is perfect in time because tuning, everybody, there is many ways. I think different customers like different things. EM or enterprise manager is something that customers use. I like to rely on what we call as AWR. So let's talk about what are the things that we have done for tuning. One of the most important part about tuning is the context of what the CPU and memory looks like from inside the database is different than what looks like from the outside the database. This is because customers sometimes run multiple CDBs or multiple databases. So each database thinks that there is a lot more CPU left, and the other database thinks that it has the whole access to the system. So there has been this problem for a while. So we try to find out what is the context of the CPU and memory from inside the system. What that mean by that is we need a mechanism by which inside the system we monitor some of the CPU and memory usage. We want to change and dynamically adjust to reduce some of the brownouts that could be caused because of this, constantly increasing memory requirements. And we need to optimize them so that we automatically do it below the covers instantly. So what does that mean? So let's say, there is an increase in certain structures of the, internally. As we monitor more and more memory usage, we want to make sure that we optimize or resize the increments of the structures so that, memory can be taken in bigger chunks, and therefore we can optimize it. Now, again, we want to be careful. We just don't want to go arbitrarily and grab all the memory. So therefore, our monitoring comes into effect. We also try to, at the same time, reduce the usage from some other components. That way, we try to optimize CPU and memory usage and reduce brownouts. Now, this is something I've talked about a lot. If you want to look at it, there is a whole view on that. It starts with $, $, GCR. You can look at all the collected statistics and how we act on it. Now, it's one thing to collect statistics, it's one thing to report it. With RAC, we have made it so much more easier that we have integrated AWR, ADDM, and we have what we call as a single consolidated AWR. So you can look at some of these things. Now, what you want to do is the ADDM also provides you information on tuning sequels, even in a RAC environment. Sometimes the suggestion is to look at the RAC specific statistics. So it's kind of very nicely done. We talked about reconfiguration. Now in reconfiguration, you can look at some of the times provided. So you can see that we have provided you a breakup of the timings on reconfiguration. The same thing with DRM. We try to tell you that, hey, yes, this, the DRM was helpful in so many cases here. As you can see, we have broken it up into a lot more details on that. We have this global AWR, which means you're running 4 nodes. In one report, you can see everything. So here you can see that node number 1 is a lot more busier. And then you can see that node number 1 is also doing a lot of physical reads and redo. So it's about 8 times some of the other nodes. So this is something that can give you an insight into multiple nodes running different workloads, but you can see it at what we call at a higher level. Now, once you know that, now you need to know a little bit more about the messaging aspect. So we have broken everything down, the blocks, block received, how much was done, and all those information we have provided you across all the nodes in one report. So this helps you with your tuning ability, so you don't have to do it individual nodes. We also have this Exadata configuration statistics. So for Exadata, we tell you what we call as histograms. So histograms shows that what percentage of your time was spent in which bucket. This is very important when tuning. Having said all that, again, this is not just all about one or typical individual feature which affects one customer or one kind of thing, you can see that it is the number one choice used by many customers. You look at different variety. There is a finance, there is mobile companies, and there is different kinds of users, insurance, travel companies. They all use RAC. Different kinds of workload. All these features make it so much easier for them to scale, and more importantly, you can use it depending on how you want to use it. You could use it on generic systems, Exadata, RAC in the cloud, the autonomous database. They all use RAC below the covers. Now, with that, I would stop here. I think I have exceeded my time by a minute and 50 seconds. So sorry about that. So this is all I wanted to share. I hope it was useful. I will take a look at questions in a minute. I see there are some questions here. So let me move it to a separate screen. All right, so I'll just go through the question and answer it one by one. So there is a question which says, which parameter has to be configured to change LMS? Well, it is auto, and it's based on a number of a number of CPU. You don't have to change it. There is a GCS server process parameter, which I would really, really encourage you not to change. Let us know if the automatic thing doesn't work. Why grid infrastructure management repository is optional? Well, as we found out, customers did not like to provision this upfront, so we gave them a choice. So yes, you could still use it. It is very important. It's very good. I have talked about it multiple times in my previous presentations, but some customers, or a majority of customers, did not like the notion of pre-allocating it. So now we give you a choice. Memory guard available to on-prem or Exadata? No, memory guard is a generic feature. So you could use it on all the systems you have. About Recovery Buddy, is it available to only Exadata, ODA? No, again, Recovery Buddy is also generic feature. Mira is already available in thing. What is the additional different features added in Mira? That is a very good question. Maybe I will answer that at the end because it will be a little bit more information. So let me go through the rest of the question. Autonomous DB. Oh, wow, it's moving. RAC is also automated. Well, as a customer, as a user, autonomous database, you only use a service. Behind the scene, yes, RAC and all the data center operations are automated. How Oracle Tracefile Analyzer generates a real-time summary in 20C? Can you elaborate how we can utilize in our daily operation? Okay, that is a very interesting question, but that would require me at least 20 minutes. So probably I'll take you offline one-on-one with that. Maybe we can schedule another session which just talks about that. I can get Sandesh and myself to talk about that. Yes, YouTube recording will be done, and does Autonomous DB use TAF in the background? Well, it uses what we call as TAC, Transparent App Continuity. Just about the Mira, there are two different cases of failures that we have taken in Mira. So in 19C, we have fixed one feature or one failure case, and the other failure case is available in 19.7. So let me know again if you're using it and want more detail. I will probably do, or maybe have my colleague Peter do a Mira specific session, which we can have a lot more details on that. So with that, I think I answered all the questions. Sai, Chandan, take it over. Thank you again for attending. This is going to be recorded. I'm sure you'll be seeing all the links to the recording very soon for all those registered participants. Thanks once again.
Yeah, thank you very much, Anil. Anil, can you stop sharing?
Yeah,
I can.
Yeah, I'm going to stop sharing in 1 second. There you go. Can you see that? Yeah.
Yeah, thank you. Many thanks, Anil, for your continued support and time. We really enjoyed your presentation as always. Hopefully, we will get your time for next presentation very soon. Hello, everyone. As I suggested earlier, please use hashtag and Anil's Twitter ID at RACMasterPM, and you can thank him by tweeting or posting in the Facebook. We will send you the speaker survey today. tomorrow. To all the registered participants, request you to spend few minutes of time and complete the survey. Then you are able to access the presentation. We are also happy to issue certification of participation. If you attend all webinars in the month, reach out to webinar@aiog.org. It's a email ID of us, and we will send you the participation certificate AIOG side. So this will help you in your career, in your, you can say your managers that you are spending a time to learn new things over the webinars and a lot of steps over there. So this will help you in many of the means. So it's now the exam time. Let us test your knowledge on Oracle RAC. We will have a 6 question actually. For this, you have to 70089. We will wait 2 minutes, and we see means how many participants is there. Log into the menti.com. Use code 670089. Yes, please join. Please join menti.com. And the code is 670089. So we have 6 questions. You have to answer very fast so that you can earn more points to win this quiz. Wow, we are getting more participation. Let's wait for a few more seconds. Yes. Aha, great. We have a good number of participation now. Great. We did the century now. Aha. So let me start quiz now very quickly. So I hope you all are ready to go for first question. Answer fast, you will get more points. Times is up. Let's see. Wow, 40% has answered correctly. Here is the leaderboard. Let's see who is fastest. Aha, Alexander Marty. Wow, that's great. Let's move to the another question. Time is running out. Time's up. Wow, this time more person have answered very quickly and correctly. That's great. Let's see who is the leaderboard now. Aha, that's great. Alexander is leading the board. Wow, great. Let's move to the third question now. Keep on playing. things will change at the last moment also. So 3, 2, 1. Time's up. Aha. Wow. 81% answer correctly. That's great. Let's see who is in the leaderboard. Aha. Alexander and Girish are leading the board. Wow, that's great. There is a huge competition between these two. Yeah. Let's move to the fourth question now. Answer fast so that you will get more number of points. Time's up. Great. This time 50% has answered correctly. Let's see the leaderboard now. Haha. Great. Yogi is moving now. Great. Let's go for the next question. Your time start now. Time's up. Wow, that's good. Let's see the leaderboard. Aha. Things are going to change now. Alexander is still on the leaderboard. So this is the last question. Answer fast. Time's up. Aha. Wow, 46% answered right. Correct. Let's see the final winner now, final leaderboard. Oh wow, this time Yogi has did a good job. He has moved to the next level and Yogi is the winner of this quiz. Thank you, Yogi. Thank you very much. I think you should provide a full name so that we can identify your name in our list and we can connect you. So please, give your name on Twitter or your YouTube channel so that we can identify you easily. Thank you, Yogi. And we have next presentation, next session on the database fleet modernization with Oracle Autonomous Database from Chris Bhanushali. So basically, it covers how is data management different today than it used to be. See the key services feature as such online scaling, rolling, patching operation, and auto indexing in action. So join us in this webinar next Wednesday, 13th May, 8 p.m. IST. Thank you very much. Thank you all for joining us. See you soon.